Good morning, everyone. Hope you are doing well. This is Ms. Pamela giving the physics course for grade 12 American System. Today we are going to study chapter 18, section 1, Refraction of Light. If you all can please open your books on page 492 so you can follow up with me. We already started with this section, so we are going to do a little bit of revision before we continue. First of all, refraction. Refraction is when light crosses a boundary between two mediums and it bends. For example, you can see figure 1, page 492, which shows several examples of refraction. Here in the figure shown in front of you, you can see light passing from one medium to another. The incident ray hits the boundary between the two mediums and the light changes its direction. This is what we mean by refraction. The angle between the normal, which is the perpendicular line, and the incident ray is called the angle of incidence, while the angle between the refracted ray and the normal is called the angle of refraction. Note, refraction depends on the properties of the mediums that the light rays are traveling from and into. So when the properties of the mediums differ, the refraction and the angle of refraction differ. Index of refraction. Index of refraction is a value specific to each medium according to its properties. It determines the angle of refraction in the medium. You can see table 1, page 493, which shows different indices of refraction for yellow light in different mediums. So, index of refraction is different for each medium, and it shows what the angle of refraction will be. To calculate the index of refraction of a medium, you need to know the speed of light in that medium. You use the following equation. N is equal to C over V. N is the index of refraction and it has no unit. C is the speed of light in vacuum and it's 3 times 10 to the power 8 meters per second. And V is the speed of light in that medium. And the unit is, of course, meters per second. By rearrangement, we can also calculate the speed of light in a medium if we know its index of refraction. We use the following equation. V is equal to C over N. C is the speed of light in vacuum, 3 times 10 to the power 8 meters per second, and N is the index of refraction and it has no unit. Your answer will be in meters per second. For example, what is the index of refraction of a material through which light travels at a speed of 1.25 times 10 to the power 8 meters per second? First, we write the given. The given is V is equal to 1.25 times 10 to the power 8 meters per second, and N, which is the index of refraction, is unknown. We use the equation N equals C over V, equal to 3 times 10 to the power 8 meters per second over 1.25 times 10 to the power 8 meters per second. The answer will be 2.4, and it has no unit because the units cancel each other. In the second part of this section, we are going to study Snell's law. Snell's law shows the relation between the indices of refraction of two mediums and the angle of incidence and the angle of refraction as light passes from medium 1 to medium 2. N1 sine angle 1 is equal to N2 sine angle 2, where N1 is the index of refraction of the first medium, angle 1 is the angle of incidence, N2 is the index of refraction of the second medium, and angle 2 is the angle of refraction. By rearrangement, to calculate the angle of incidence, we use the equation of angle 1. It's equal to sine minus 1 and 2 sine angle 2 over N1, where sine minus 1 is put on the calculator as shift sign. To calculate the angle of refraction, we use the following equation. Angle 2 is equal to sine minus 1 into N1 sine angle 1 over N2. To calculate the index of refraction of the first medium, we use the following equation. N1 is equal to N2 sine angle 2 over sine angle 1. To calculate the index of refraction of the second medium, we use the following equation. N2 is equal to N1 sine angle 1 over sine angle 2. For example, what is the angle of refraction of light that passes from air, N equal 1.0003, into diamond, N equal 2.42, if it hits the boundary at an angle of incidence of 20 degrees? First of all, we write the given. N1 is equal to 1.0003, N2 is equal to 2.42, angle 1 is equal to 20 degrees, and the unknown is angle 2. We can draw the figure showing a refraction of light in this case, so it makes the problem simpler to us to solve. We can see in the figure light passing from N1 to N2 and bending. So use the equation of angle 2 equal to sine minus 1 into N1 sine angle 1 over N2. We put the values and the answer is 8.12 degrees because angles are measured in degrees. Please, as a homework, solve numbers 1 until 5, page 494, and read Connection to Astronomy, also on page 494. Thank you and good luck.